Good morning, Saturday morning here. Ed, the CNC Dude here, Suncoast Technical College. It's February 5th, a cloudy day in Florida, a miserable 65 degrees. It's terrible. Just took Sydney for a walk. Just walking behind me right now. She's going to jump up on the bed. Not jump, she's 10 years old, so. We're going to look at, let's see, I'm going to go into my Fusion storage areas, my class storage, and the machinist class. Here we have Monica, who was working on her Titan projects here, and I gave her making a spider web down there, a project, this one here. She called it the Charmander. So it says version 8 there. So I gave her a picture of it looks something like this. It was in a milling vise, and I said, oh, that would be cool to make. But I'm terrible at drawing, and the best I can do is scoop stuff from GrabCAD when it comes to that stuff. So can you make something that looks like this and just kind of keep it in the 3-inch diameter range, you know? Not too big, not too small. All right, so, and she actually started to do some programming. She got pretty far. So this is her model design. It's actually, this is all what we call a stereolithography file, or otherwise known as a STL file. And these are all like facets. So, you got mesh bodies, I'm not, honestly, I don't know what the difference between these two are, other than this is mesh area. I didn't get a clear explanation of how she designed it, but when we tried to do the manufacturer side and kind of jump in and see where we're at, doing this is, and our computers at school are not the best. We were kind of struggling with this, and we're not sure why. So we made another folder here. And we actually saw some videos on how to convert or an STL file to a solid model file. So we said maybe that was the issue. We go back to design here. And the lesson we saw were mesh, modify, where is it here? Convert mesh. And I actually tried to do this one. I really couldn't do it. So I literally exported. I did, let me do here. File, save as, and I don't know what my, hold on a second. A lot of noise on my TV. I am back. I think I'm back. Not pause. Here we go. Back on again. So we did, couldn't save as, because that's going to save as a Fusion file. Want to save, I think we did export. Export, and we picked STL. We export as XTL. This is kind of what we do if we have a Fusion file. It was designed in Fusion, and we want to move it to Mastercam. We got to save it as a generic file, like step, or definitely not STL. That's not your best choice. I guess we could have exported as something else. We wanted to learn the import thing. So we exported, and then we followed the instructions on the video. We did insert mesh, we've done insert mesh on bringing in a model of solid material. So, but it's kind of like, I guess it's kind of redundant. So, but anyway, we changed that. And also we had some of the project manufacturing team working on it. So this is the imported file. So now it's just one body, and I had to name it convert. So it still has, it looks solid, but it still has these flats are, I guess, what you call a diamond facets. So it's got one ring. I learned in Mastercam, like if you're importing stuff, make sure you get the wireframes. So this has no wireframes or sketches, so it may be challenging. We left this alone, and this was the project manufacturing group also looking at it because we need some more training. And we started to use like the existing code or the selections, and then we decided to just do a do-over. So, and plus we went to bigger tools because Monica was trying to do it with 1/4 inch diameter. We wanted to go to 3/8 a half inch on the roughing process. All right, so here we are. This is it's still generating, and I have turned on here. Is this preferences in here? Preferences. I tell the students to turn on some things when manufacture, enable cloud libraries, and if you turn all this stuff on, it's almost like too much information. But show operation machining time. That's one that could tell you right away if the machining time of that operation. And highlight tool passing. So I haven't, obviously, I haven't tried all this stuff. So we do that, and we on our units of design, we make sure because we're pretty much all doing inch. We want the default to be inch. On the general side, we have the Z up, and we like to use the SolidWorks mouse configuration versus the Fusion 360 one. So as far as basic setups, and under preview features, now in education, we actually have more access to the manufacturing extensions, but like the multi-axis stuff, but our machine simulation. But we've actually turned on post-process NC code with legacy post. It's just our preference in the school to use the G1 tab to produce the code versus the NC program area, even though we have it here. So we wanted to like learn the benefits of either one. So everyone here, you can see right down the line here, what's taking the most time. These are all pretty much duplicate scallop operations, the operation, but it's from different orientations. 8 minutes, 8 minutes. So if I go to the right click and I click machining time, right here, it's 1 hour, 5 minutes. So somebody took a guess it took 1 hour, and that's about right. In reality, it took longer because we have to overcome hurdles when we start to do stuff we haven't done before. We're actually surprised the tail was able to cut, so... All right. How can you make improvements? Like on these operations here, if you're using the Titan, we call it the Titan tool library, but in your tool library here, in the cloud, we have our tools in the cloud. So if we are working out of the Titan building blocks aluminum one, and we pick, this is the basic library that we use. Titan uses, we use the same library. Milling, right? Milling tools, end mills, and looks like Little Mo wants to get out. These are our basic tools, right? We got them by size. And if I say 3/8 end mill, right here, I got all these settings here. We've already set and discussed about what RPMs like this will be our slowest machine can turn 6,000 RPM. We calculated that for aluminum, we could be way faster than that, but we'll run it at max RPM. But we have our feed rates already set, and we're already lined up to feed per tooth, and we have the tool described correctly. And as far as adaptive 20, so we want to use up in here, I have it described. And I have the feed per tooth at 20% for that tool. And this would be the plunge rate. And down here it says step down. So that will go into your adaptive settings, how far down you could go. and could reset the default and step over. So in here I'd have, if I double click on this, originally had the library be linked to I'll just show you for a second. Tool underscore diameter. Oops, sorry, I forgot to spell it right. And you can't use capital T, I found that out. Times, let's see, that'd be 0.2. So that'd be our step over. So if I actually end up copying the tool, I really don't have to change a lot of data. So hit accept, and that gives me 75 thousandths. So, or you can plug in hard numbers, but I'm trying to use the parameters more. So over here, I select, even if I forget to select up front, I got my selections here, and I could pick one. So this is going to be 4-axis, so we thought we'd be a little bit, normally we're doing 30% regular vice job mill, and we decided to be a little bit lighter, 20%. So this is running machine, our other machine can run 8,000 RPM, so we have a advanced library, so we can take advantage of that one. And we have 3,000 per tooth, so we're a little lighter on the feed rate and less on the step over. So these are all pre-settings in here. So this is going to give you your how long it takes calculation. And when you're at machine, if you're happy with all this stuff, now we have the time it takes to do these, right? To edit the tool right here. So we're using, looks like we had this fast and finish contour. So if I did fast, it's like 3,500 per tooth, and finish, which is 2,000 per tooth. And then custom would mean that somebody overwrote something. So if I'm on finish content, I'm looking for the best finish. I click OK, and it recalculates the time. Any year now. That says 40 minutes, right? Oops, still not calculating. But some of this stuff is, I got rest machining turned on, so it's trying to calculate everything. Let me make sure it's updated. Yeah, 40 minutes. And some of those settings like 3D contour are also got the step over here. Step over 5,000ths. So I may actually start adjusting this to step over. So usually for calculation purposes, if you put the numbers big, it'll calculate faster, like 25 thousandths. But in this case, we'll say, let's cut the step over in half, right? That's the spaces between cuts. And this is going to be like trial and error. How good does it look? And I'll tell you this, if you shut all this off and do the stock simulation, it's kind of close. So it depends on your graphics. So, but that's now 20 minutes, right? All right. So if I go into here and say, I think we could go 3,000ths per tooth, right? That's 1,000th more per tooth. Now we're at 13 minutes, right? Well, let me just compare this. I kind of got 2,000 per tooth there. This one's got step over of 25 thousandths. So that was like a basic setting, and I believe that's how we ran it. So as far as time, right? So edit. So in this case, if I do 0.025, okay. This one's got more feet per tooth. Now we're down to 5 minutes, 36 seconds. So as far as how it looks. So if we're out there, I can actually turn the feed rate knob up like another 1,000 would be like 30% more. And if I had more RPM, I could do the same also. But I'm just going to improve these to 3,000ths. Edit. Okay. See, now we're down to 5 minutes. Because all these operations were duplicated with our basic settings, and you're just changing which way you're pointing in the z-axis, pretty much. All right. Now we're down to a total time of 51 minutes. Okay. So we can, keep on stepping on. It actually cut pretty easily. Maybe our adaptive settings were also a little bit, we could have been even more aggressive on that. So the same thing. How on adaptive, the true nature of 3D adaptive is getting close to the curve. So so on the step down, which I like to call step up, it's how far can I cut the first cut and how close to the shape. And that would be these settings here. So you got maximum roughing step down. That's how far down you can make the tool go on the first level. And step up. So by default, if you got it set at 0.8, it's going to do 10% step up. If you want to stay closer to the curve, like you're doing hard metals, and you don't want your finish tool to struggle, you can change the step up to smaller numbers. But it's going to also take more time. So, and all these things. So the optimal low settings preset on the percentage of the tool. So this one here, that's what optimal load is to step over. And it's a little bit more than that. It's radial engagement, and this is all called technically trochoidal milling, so which is superior to regular old pocketing. So, and now we're getting into our standard now is adaptive for all the roughing and pocketing for a nice looking floor. Because your adaptive is not meant to make nice walls. It's just roughened material. So you want to use contour and pocket for walls and floors. Or you can just use pocket by itself if you turn on finishing passes. So those are the goals there. All right? So as far as time goes and stuff like that, that's pretty much it. So I did simulation, and I was also trying to simulate it in an Autodesk simulated machine. Only this, I don't think there's a 4th axis one in the library. And I haven't had time to make one. So, all right. So if I am in, let's see, operation, I also notice operation runs fast, but lately in class we've been using comparison. So comparison is compared to the model. I'll press play. So this appears to be red and overcutting because it's kind of based on a couple of factors here, like view, model, opacity, stock to leave on your setup. So under setup, this one here, edit. Look at this. So I got it linked to my machine, so we make sure we get the 4th axis involved. Right here is, I need to turn on the model of the part and not include the model of the material, because we actually made a model of the material. Every time you change something, you got to regenerate it all and hope it doesn't take a million years. Depending on your computer strength. So my computer is, let me turn on my free C cleaner. It's actually got information on it. Right here it says, I have an Intel i6 Windows 10 Pro 64-bit 3.4, 32 gig of RAM, and I have a digital hard drive, and I'm running an NVIDIA Quadro K620 card. Not the latest and greatest, but it's not bad. So, all right, let's go back to, now a lot of this simulation time is kind of dependent on if you actually select too many things, it's going to slow that down. Like if you're doing rest machining, it's looking back at other operations. If you're doing a lot of like on your adaptive setting, if you're doing stay down levels, like not least, that's more calculation time. So if you set everything loosey-goosey and you can get through your calculations, then you can start plugging in more stuff to make it faster machining but slower generation time. So like this, these are all regenerating. Or if you're doing operation 2 and you have the used material from preceding operation, that's a really nice feature, but it's slower simulation because you have to every time you change something, you got to regenerate everything. You know, everything's based on the previous operation. So, all right. We already know our time is like 50 as soon as this one gets done. I should have just paused. Okay. So I hit simulate. Now everything's blue. Blue is extra material right here. It says blue is positive, green is the model, red is I went too far. Hang on there, little Mo. All right. Cut. We make sure we didn't want to cut around the back because that's where we're holding it. We had to build a barrier in adaptive in order to keep it from going there. And actually, you learn stuff from other CAD CAM. I actually learned that in Mastercam personally, how to create boundaries, because the OptiRough is kind of how that's driven. Where you put your fence. So, all right, so that's all roughing. Now, still roughing this side. So, all right. Let me recenter it. Going around the tail. And then we're going to get into more finishing. Now it's getting green. And this isn't full, well, fourth axis would be 3. This is what we call technically 3+1, which you're not going to hear too much because everybody's doing 5 axis. But you got to work with what you got, right? Let me pause one more time. The other thing I have on my settings for simulation, I have on a tail, which has got toolpath that disappears as it goes. So you can play with your settings when you're doing that. I like seeing the toolpath. I'm an old G-code programmer guy, so I like to know where the tool's going to go. So, and this is I think it's a 3/8 ball end mill. And we actually had to do this at a 45-degree angle. So notice that there because of the tail, actually. Oh, crap. Let me go to the end. And which is more calculation time. Okay, while we're waiting for that. So actually comparison mode is also longer because it's trying to compare to the model versus operation right there. So it changes colors by operation. But pretty much, it's still working. So if you start to look at it from a multi-axis point of view, this surface here, we really couldn't cut that well. It's trying to attack it from all sides. It did get part of the round feature here. We couldn't get underneath. There's a gap underneath the tail. And we wanted to try to make sure we could get at this from different operations. So you probably could have added another one from this point of view. Get from this side. So it's pretty much the angles of attack, right? So we just don't have the advantage of the 5th axis, like machining from the top. Like we can't tilt like that or tilt like this. So that's the advantage of 5 axis, but you work with what you got. So it's actually 4th axis. You can learn pretty much almost all of what multi-axis does. This with your limit of travel. So learning how to hold material, learning how to do tool orientation. You can do up here, you can do multi-axis, these here, and some of these 3Ds have a multi-axis function built into them. So you can learn like Morph does. I think Morph does. Depends. If you see a thing with a plus button on here, that's a multi-axis add-on. Of course, that's got to be in your extensions. But if you're learning Fusion, you got everything. You got everything. You can learn anything you want. So even when we go back to a Titan 200M, and we can machine that virtually very easily. So if I go to my teacher file, and I have some students working on that now. I got my 200M right here. I did a simulation machine. Tyler's trying to like figure out how to do it in 4th axis, so I made a copy of his. So this is my this is kind of based on my talk about how to do it. Any year now here, come on. A lot of data in there. Right there. So this would be operation 1. So in the vise, machining the top, but if you did 5 axis, you're tilting. So we're just using a device as the holding fixture right now. And then we do operation 2, which would be this way. The nice thing about the square cube is you can just squeeze it on the square cube and be totally aligned with the rest of it. And my video has all that tilt stuff in there. And I have actually Haas 500 SS from my friend Steven Hadwin at 3D Machining in Oklahoma. So he shared his post processor with me and stuff. And I did just a manual. I like doing manual comments. Like that gives me stuff, helper stuff on the G code if I'm at the machine, like setup information. So I got broken up in 2 operations. So, but we're going to be tilting. I don't want to get into this too much. I actually have a video on that. So I'm at the 26-minute mark. So I really should cut this video in half. But I'll post this and see what you guys think. Okay. Talk to you later.